Hey guys, how's it going? It is Mr. Blake, and I wanted to just do a quick little add-on. This isn't actually in your notes, but in realizing what I left you with the sub, I realized though it might have been mentioned in the video. I'm not 100%, so I wanted to cover it because it is kind of a big deal. In my last lecture, I talked about two elements being what we call diatomic, and diatomic two atoms. That means when we find them in nature, they're always found together. The ones I listed, I believe, were hydrogen and oxygen, but they're really not the only ones. And in looking through some of your examples, if you've gone through some of the homework answer keys, which are online, hopefully you picked up on this and saw that there were a few things maybe a little funny in that hydrogen and oxygen aren't the only two. So just real quick, very briefly today, I wanted to let you know what they were. The difference between monoatomic elements and diatomic, and the answer is really in their names. Monoatomic are like most elements, and most elements do fall into this category, where they're only made up of one element. So if I say iron, for example, and not iron as part of a compound, but just iron, I mean Fe. Okay? So all we would do in that case is we would write the symbol down. Okay? So if I had, and here's the example here, sodium. Okay? So sodium, or Na, is just sodium. It's not part of our group of diatomic. Okay? Our diatomic elements are special, and depending on who you talk to, they usually correlate it with some sort of German name. Brinkelhoff is what you can see written here. Sometimes people switch the H and move the H, the hydrogen, first and put Hofbrinkel. But what I'd like you to do is just take a moment, and I'd like you to write down these elements right here. Okay, bromine. Yes, I'll zoom in here a little. Here we got bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Those elements are what we call diatomic. Okay? So when you get a word equation that says hydrogen plus oxygen makes water, before you even balance it, and this is really important in the balancing part, you can imagine the hydrogen and oxygen portion, you have to know just instinctively, or have memorized it, that those are diatomic elements. So when you write them down in the formula form, you would write H2 plus O2, as opposed to H plus O. That would be incorrect. So if we continue on, you're going to see quite a few examples. They're going to always have a subscript 2. Okay? And these, honestly, if you look at most of them, a lot of these are these are nonmetals. Right? You can look at every one of them. They're all nonmetals, and a lot of them are in group 17. They're halogens. Okay? So if you were to see bromine written down, and then you were to translate that into the formula format when you wrote down that chemical equation, you need to know that it would be Br2 and not just Br. All of the other elements that are not part of the Brinkelhoff or Hofbrinkel, I'll probably say Hofbrinkel a lot, but you just wrote down Brinkelhoff, so that's fine too. Both are good German-sounding names. They're going to be diatomic all the time. Now, they're only diatomic, and this is so important, they're only diatomic when it is just that element. If bromine or fluorine or chlorine or hydrogen are part of some larger compound, they do not have to have a 2 in the subscript. And if you think back to how many times have you written down sodium chloride in our examples, right? Sodium chloride, did you see Cl2? No, it's just Cl. The charges determined how many chloride ions that you needed. Okay? And that would be true even in molecular compounds, okay? Or ones that are held together by covalent bonds. So be aware of that. All right? So I just want to do 2 quick examples with you guys so you can see when they're used and when they're not used. The first one is a pretty simple reaction. It's sodium chloride. Again, that's a common compound that pops up all the time in our examples. And fluorine. All right, so fluorine is a gas. It's written in red on the periodic table. So what happens when you take that salt and you combine it with the gas? Well, the equation in the word form tells us that it makes sodium fluoride and chlorine gas. So the fluorine and the chloride ions swap. All right, and we'll get into later what type of reaction that is in just in a different unit. All right, so let's look first at sodium and chloride. I hear that "ide" and I should be thinking ionic, right? Anytime you see that IDE ending, and you don't see the mono or anything like that, or more importantly, right, if you analyze the first thing, the first part of the compound, okay, you can see that sodium, right here, if I just analyze that portion, sodium is is it on the left or the right side of the staircase? Right, well, sodium is way on the left, okay, and those would be a metal. Okay, chlorine, sorry for the terrible penmanship, chlorine, or chloride in this case, because it's in the ion form, is on the right side, so it is a non-metal. All right, altogether, that's going to make this, if I have a metal and a non-metal, an ionic compound. Okay, so we know that this is an ionic compound just because it's a metal and a non-metal. Let's look then at how we're going to put this together. So sodium is a 1+, and chloride is a 1-. And I know that just by looking at them, looking up those elements on the periodic table, and by looking at what group number they're in. Sodium is in group 1, so it's everything in group 1 when it forms an ion becomes a 1+ charge, and chloride is in group 2, excuse me, not group 2, group 17. So everything that is in that group with the halogens takes on a 1- charge. All right, so when I put them together, they're in a 1-to-1 ratio. Now fluorine, okay, is one of those Hofbrinkel elements, or Brinkelhof. Okay, and again, you need to have that memorized. So if I see fluorine, it's not just F, it is F2. Right? If I continue on, sodium fluoride, sodium again is a 1+ fluoride ion, also in group 17, is a 1-, so it's a 1-to-1 ratio. And chlorine, this is an elemental form, it's not part of a compound now, it's just by itself, is also part of the Hofbrinkel, or Brinkelhof. It's the Cl portion of that, so it is Cl2. Right? So that's how you would do that. And then, of course, we would go on what we learned yesterday, is you would go on and then balance this. You would do all the tallying up. But it's important that you start off correctly. Without doing that, you know, it may not balance at all, or it may balance, but it'll be incorrect because you had the wrong subscripts to begin with. Okay? And those subscripts, excuse me, those coefficients, after you balance them, if they're wrong, it really makes a big difference down the line. Okay? Let's look at another example here where you have two elements, aluminum and sulfur, by themselves. They're in their elemental form. They're not in any compounds. They're not in an ionic compound or molecular compound. They are just alone. But they're not part of the Hofbrinkel group. So when I write aluminum and sulfur, I simply leave it as Al and S. Okay? They are not in that Brinkelhof or Hofbrinkel group, and so I can leave them as is. Aluminum sulfide, again, aluminum is a metal. Sulfide, on the sulfur on the right side of the staircase, is a non-metal. So I have to look at the charges. Aluminum is in group 13, it's a 3+, okay? And sulfide is a 2-. So it takes 2 aluminums for every 3 sulfide ions, and so that way I get 6 positive charges and 6 negative charges, aluminum sulfide. And again, from here, what I would do now that I've transferred it in, I would go in and then I would balance this, and this becomes a pretty easy balance to do that. So just be aware of that. I just want to go through a few examples. Make sure that when you guys do this, you are always being conscious, always kind of rehearsing Brinkelhof, Hofbrinkel, whatever works for you. But you're always looking at that. When you see elements by themselves that aren't a part of compounds, you need to sort of vet them and run them through that question. Are they part of this group? Because if they are, you need to write that too as a subgroup. All right, hopefully that helps, and I will see you guys later.